Okay, so I'm going to go over the last part of 17.2, essentially the part on how do you get the equation when I give you the graph. Well, we have our standard forms right here, where it's a times sine of b times x minus c, and you're going to add d to the entire thing. Only differences between sine and cosine. Well, if you know a, b, c, and d, you can just plug it into the standard form and you have an equation. Underneath, right here, I give you the steps on actually how to find it. Your a and your d, I kind of expect you guys to be able to find a max and a minimum value on the graph, and you're looking for the y. So when I talk about a, to find a, we really don't even need the absolute value part of it. So I can erase these. And as far as I'm concerned, you don't have to, when you write these, you don't even need to do a reflection, so you don't have to concern yourself with the reflection. What we're going to do, this means you're going to take the maximum y value and subtract it from the minimum y value, and then you're going to divide it by 2, and that's going to give you your amplitude. So let's do that for this graph over here. Well, we can see here, my maximum occurs at 1, this is 1, and my minimum occurs at -5. So to actually find my a, what I'm going to need to do is I'm simply going to take that 1, my maximum, minus -5, my minimum, and divide it by 2, which is nothing more than 1 plus 5 divided by 2. And that is going to be 6 divided by 2, which is 3. So my a is going to be 3. The next thing we need to find is b. To find b, we actually need to know what the period is. The best way to find out what the period is simply go from maximum to maximum or minimum to minimum. It's the easiest and most obvious way to see how long it takes for the wave to repeat. Well, I have a maximum that occurs right here at 3 pi. And I have another maximum that occurs right here at 11 pi. Well, we need to find the actual distance from here to here between 3 pi and 11 pi. The way you do that is you simply do 11 pi minus 3 pi, and that's going to give you 8 pi. Now that's only the period. To actually find b, we're going to do, my b is going to be 2 pi divided by 8 pi, because 8 pi is my period that I just found up top. Now we need to reduce our fractions. The pi's go away. 2 and 8, the 2 becomes a 1, the 8 becomes a 4, so it becomes 1 over 4. So now I have my b. So now I have an a and a b, and we just keep cruising on along. Now I'm going to go ahead and find d, because d is pretty straightforward to find, because we already found our max and our minimum. Our max and our minimum we used to find our a, which was right here. It was 1 minus -5, but now we're going to do 1 plus -5. 1 plus a -5 divided by 2. Well, that becomes nothing more than 1 minus 5 divided by 2. Well, what's really nice about this, 1 minus 5 gives me -4 divided by 2, which just gives me nothing more than -2. So now I have my d. I have my a, my b, my c, and my d. Well, I don't have my c yet, but I have my a, my b, and my d. Now we have to find the c. We're going to find a sine and a cosine wave, and I want to show you how to do that. So let me clean up my graph here real quick. Okay, let's do the cosine first. Cosines always start at a maximum. So we're going to look, and we have a maximum right here. And this point right here where this maximum occurs is at 3 pi, comma 1. We went over 3 pi on the x, and we went up 1 on the y. Well, really, we have to move it over to the y-axis because cosine, it has its maximum, the original function, on the y-axis. So we're actually going to use 3 pi, in this case, for my c. So we're just going to plug c in. C for cosine, I'm going to say cosine, my c is going to be 3 pi. Alright, so now we have C for cosine. Let's find out what C is going to be for sine. So my sine, the C, in this case, over here I say that you need to find a midpoint where the graph is increasing and use the x value. Well, let's go ahead and just clear this part up. And we have to find the midpoint. First things first. My amplitude's 3. So go to your maximum right here and count down 3. 1, 2, 3, which is going to put it at -2. Well, conveniently, if we count down from -2 to the minimum, 1, 2, 3, it's right in the middle. So draw yourself a little midpoint line right here. Right on -2. That's the middle of the wave itself. We need to find a point where it's on that midline and it's actually increasing. If you look right here, this point, it's on the midline and the graph is actually increasing. We wouldn't use this one because yes, it's on the midline, but it's actually decreasing. So we'd want to use this point right here. Well, that point is pi, comma, -2, but we're going to use the x value. So for sine, we're actually going to use pi for my C. So when we put this all together, this graph, we just essentially found two different equations for this graph. The equations, when we put it together, for sine, it is going to be, let's see, A is 3 sine, let's see, my B is 1/4, so we're going to do 1/4 parentheses x minus, my C is for sine is pi, close, close, and we went down a -2 for my D, so it's -2. For cosine, we're still going to have 3, but now it's cosine, my B stays the same at 1/4, we still have x minus, but now my C was 3 pi, close, close, and we still have the -2. So you have two different equations here. Now, once I have a sine wave or a cosine wave, and I simply want to find another one, I can just add the standard period of 2 pi to my angle right here, which is my x value, my x shift. Because if I move it over 2 pi, that's the standard period, and we move it over, and it's the exact same wave. This is essentially an angle in radians, because that's what my x values are expressed in. And we learned about coterminal angles where we just simply add 2 pi to find another coterminal angle, which will give you the same answer.